Welcome to GenTech, your general technology channel.
This is my USB-powered PC speaker set, and I've had this for about 5 years now, and it only worked for 2 weeks. Each of the speakers is rated at 4 ohms, 5 watts, and they're still working. This potentiometer, or volume control, is defective, so I'll be replacing the whole amplifier board with a new one. As you can see, this was powered by the MLX3007 amplifier IC, which I think lacked the power to drive the speakers. At the time when the volume control failed, there weren't any suitable replacement I could find until just recently when I searched the internet that I found the PAM-8403 amplifier board.
This is a very small yet powerful amplifier, which has the following measurements. The board's width is 2 centimeters and 3.5 overall. The length is 3 centimeters, and it has a height of 1.3 centimeters. It is relatively small, but I am just amazed with this amplifier. Just look at these features. There are 3 features that I like the best. First, the efficiency rating of 90% means that only 10% of power is lost, meaning all of the power is utilized properly, which also means savings on your power bills. Second, the short circuit protection refers to the speaker output. If there are accidental shorts on the terminals, the amplifier will be disabled and would revert to normal functions after the short circuit is cleared. Third is the thermal protection, which is a maximum of 140 degrees, which means it will shut down when it reaches that maximum temperature and will resume normal operation after it cools down.
And this is it. The PAM-8403 amplifier IC on the HW-012 printed circuit board, which, by the way, is the PCB layout ID. There's also the sealed 50K potentiometer, which is widely used on marine and high-end audio systems, which I like very much. One more thing that I liked is the switch that's in the potentiometer that powers the amplifier on and off. These are the terminals. Now we would familiarize ourselves with these terminals. From the left, we have the left and right speaker output terminals. This configuration tells us that all the cables are separate and does not have a common. In the center, we have the USB 5 volts DC power supply. We have to make sure that this is wired correctly since this is not protected by any means. It will be good practice for future projects to always take note of the positive and the negative polarities. Reversing the polarities and applying power to the circuit will definitely ruin the amplifier, so please be careful and always double check before you flip the switch on. Or in this case, before you turn the volume control clockwise. Lastly, we have the input terminals, of which the cables are connected to a male 3.5mm stereo jack.
For the amplifier enclosure, I'll be using this old cell phone charger casing. The width measures 45 millimeters, the length is 36 millimeters, and the height is 25 millimeters. I think this casing will do nicely. We would need to take out these 2 metal plug prongs. You can do that by heating it up with a soldering iron and just by simply pulling it out. Let's take out the charger board. Let's check if our amplifier board will fit. Okay, seems like this is a perfect fit and still has lots of room to breathe. This looks good.
I needed to put 2 rubber pads on top and the side so I can measure the holder that we'd be using. I need to measure from the board to the bottom, from the potentiometer to the top, for the volume control shaft hole that I'd be drilling.
Since the amplifier board has no holes on it to keep it in place inside the charger casing, I'll be using this flat metal sheet which I found from a very old and defective computer keyboard, which was used to make it rigid. We'll be using this as the holder of the amplifier board. This is what it looks like after I got it cut and drilled. The potentiometer is recessed about 1 millimeter in, so I had to bend the metal towards the back and then forward to have an offset. If you tighten the bolt onto the potentiometer straight away, without creating an offset, the PCB will be pushed towards the metal and the board will break. We would need to bend the top and bottom parts of the metal 90 degrees towards the back.
I didn't mention my measurements because you might be using a different sized enclosure. This is just to give you an idea on how to go about securing the board inside the amplifier case.
And now we have a holder or a chassis of some sort. Let's tighten the nut . And in goes the board. The potentiometer has to protrude for the volume knob.
There's something missing. And I know just what it is. Vent holes. Because amplifiers generate heat, so we need these holes to let the amplifier breathe, so to speak. This is the stereo jack configuration. First from the left is ground, then next to it is the right channel, and last at the tip is the left channel. To test which wire corresponds to the terminal on the 3.5mm plug, we would need a digital multimeter. We need to set the digital multimeter to resistance, and then we have to select the speaker or audio, so the multimeter will beep if it detects a loop or short circuit. So that's the right channel. The cable is white. Then that is the left channel. The cable is red. This cable color is reversed since, as we all know, it is made in China and they do not conform to international standards. I guess we're just lucky that this black wire is still ground. 2 out of 3 ain't so bad.
This is the standard USB configuration. This is right side up. The terminal on the right is the positive 5 volts and the one on the left is the negative. So by testing it, we can tell that the white wire is negative and the green wire is the positive 5 volts.
Again, not to standards, but we technicians usually don't complain, now do we?
We need to insert all the cables through the charger casing before we solder the cables onto the board. Now on to soldering. Basically, it's straightforward, since we now know which wire goes to which terminal. I started with the USB power supply. It's just the way I do it, because I really need to be sure of the polarities. Next is the cable that goes to the input terminals. And lastly, the speaker output terminals. After all the wires has been soldered onto the board, I want to show you something. I've inserted a rubber pad underneath the board for additional support. Let's close up the front with a very satisfying click. Then let's put the volume control knob. And now for more satisfying clicks. Now things are looking good. To test the amplifier, I will be using my old but trusty MP3 player, which is powered by a 5-volt 2-amp power adapter. I've had it for 10 years now, but it still works. It would be a waste to throw it out. Let's plug in the MP3 player output to the amplifier's input. With everything in place, I guess there's nothing left to do but to partay. I don't know about you, but this very small amplifier really packs a wallop. This is just great. Thanks for watching, and don't forget to subscribe.